Hello, everybody, and welcome to the Platformers. So nice to meet you. I guess that some of you don't know me, maybe most of you don't know me. I'm a new joiner to the Platformers. My name is Shani Kazaz, and here with me, Carlos is also one of the Platformers. Hey,
Yeah,
Carlos.
excited for today's topic. I'm usually one of the hosts that helped here in the platforms community. And I'm so excited to have new folks this year in 2025 join us, such as Chani as our new host and debuting in her first live stream. So we'll give it a
Sure.
minute or two for people to join. If you're joining from LinkedIn or YouTube, I think we are in other platforms, but I think those are the primary ones. Go ahead and put a comment, put a message in the comments below, and we'll see where and maybe put where you're located. Where you're located, Shani, by the way. Can you tell the
I'm,
folks?
I'm from Israel. I'm from Israel.
Israel.
Yes, now, like next to Tel Aviv, something like this, 30 minutes from Tel Aviv.
And how's the weather over there? Let me check here.
Rainy, which is weird in
Rainy.
Israel.
Is it
Yes.
warm? Or
Depend
so like
depend on who you're asking. For us, it's really cold. I guess that's where like other people, it's like super warm. 12 degrees, something like that.
12
Celsius.
Celsius. Yes. Here in the other side of the pond, we use Fahrenheit. So I need to do the math. We are in 39. I'm in the East Coast in
Mm.
North Carolina, which I complain that we got 1 inch of snow, but other folks tell me, peers tell me, like I should not be complaining. They get snow all this, they get fits of snow. But I'm from Puerto Rico, so I like the warm weather. Um,
Yeah.
so today we have a good, a great topic, right? Chani, I'm usually the host, but today the team asked me to be a guest and show some of the technologies around platform engineering of like what platforms are building. And usually that topic that we surround ourselves is with Kubernetes, like the people that watch that stream are using Kubernetes to run applications, but a lot of them are using it to run platforms, like use Kubernetes for everything. Like if there are no Kubernetes, you has abstractions to run compute, but also you can have use it as a programming language, like creating your own APIs and extending. So that'll be the topic for today, and about a new open source project that got recently released called KRO. Um, KRO. So it's mentioned KRO. So we'll be talking about today and showing some of the demos and the things that it does. It's very early project, so we'll show like what are the capabilities that are today, and then talk a little bit about what are the in the roadmap of the things that we want to do.
Yes, I'm super excited about KRO. This is an open source developed by AWS, but eventually that now it's a collaboration between all of the biggest cloud providers. So it's a really exciting project.
Yeah. So the idea started in AWS. Was one of the members of the team, and but it's very early, and that we wanted to put it in open source and collaborate with the other cloud providers and the Kubernetes community, because in the retrospect, it covers a problem or a use case that it is generic to Kubernetes, not necessarily a cloud providers, but the first use case will be like abstraction for cloud providers, and something that I also got involved when I was a maintainer of another project called Knative. We tried to create an abstraction of a deployment, for example, a deployment, a config map, a service, and ingress, and we created this API called the serving API, but it was very strict to that one use case. And then KRO is coming in as like something that you can build any APIs, any construct, any resource together into an API in Kubernetes. So if you are using Kubernetes or your DevOps or platform, um, yeah, we this is something that might interest you. So we have some, so from folks, yeah, let's start with the deck so we can start talking about it, and then you can ask me questions as we go. Shani, I know you know a little bit about Crow, but might be things that we recently did a release. So there are a few changes that we did with our second release, is 0.2. Yuri, if you can put the slides. I think I have some slides, and then we'll have some demos. And I believe some of the KRO maintainers, Amin is in the chat also, so he'll be helping with some of the specific questions. There's specific questions for it. They're saying that there's a problem with sound, Yuri. No sound. Can somebody confirm if they can hear us?
Okay,
Just
somebody said that they can hear.
Oh, there's people from Los Angeles. I don't know if Yuri can put that in.
Nice.
Show that in the screen. Cool. People are joining.
Nice.
Okay. Yeah, Mike. There's a couple of folks that saying there's no issues. And we have Osama. Yeah. Work on everyone. We're just getting started. Just wanted to give a chance for people to join, making sure that they can hear us. Okay. So I have a couple of slides, but I really we usually want to do presentations and is demos, like a lot of YAML. Like people complain that there's a lot of YAML, but in Kubernetes world, everything is YAML. It's at the end of the day, it's JSON, right? It's an API server, it's a REST API that takes JSON. But yeah, I think I did the intro. If you, I didn't. I'm a senior specialist solutions architect. That's a very long name to say that I work with end users, primarily with Kubernetes, and we have a managed offering called EKS. So I work with a lot of customers that are trying to use tools around the ecosystem of CNCF to create platforms on top of Kubernetes. So let's talk a little bit about the project. The project got released in the last KubeCon on North America, which was in, I totally forgot. Where was the last KubeCon?
November?
Where?
Salt Lake
City. Salt Lake City, yeah. With the Mid Mountains there, and there was also rejects there. So at that time frame, we released it as like an initial GitHub repo, just to see what people thought, just the idea, just to talk to folks there. We got positive feedback, and we got to be able to talk to the other cloud providers. I'm from the AWS, but we talked to Google and Azure, and recently we moved it to a different GitHub organization. So you can find it in crow.run. I'll show the repo in a second. But yeah, it changed a few weeks ago, and then a few weeks ago, the three cloud providers put out a blog post around the collaboration that we're doing with this project. So the idea with this project is that it's a project that allows you. It's a very simple project to install and to run, very minimalistic. But the idea is that we want in Kubernetes to have a way to create more. So Kubernetes out of the box comes with certain APIs, and then for the longest time, not the longest time, but at a certain point, there was a concept called custom resource definitions, CRDs, and then that exploded of like extending Kubernetes. People created all type of controllers to support multiple use cases in Kubernetes, and that's and the idea is you write a Go client code, like you write Go programming. So things like kubebuilder, you don't write. You need to know Go. That's primarily the language that is used. But you have to. It's a high learning curve of like learning Go plus learning Kubernetes. So KRO comes into creating a controller, but it's more like a group of resources come together and then creating that CRD. So, and then also on top of that, to create the CRDs, they basically have the OpenSPI spec schema. Like if you remember, it's the Swagger API, and then that is auto-generated usually through Go. But if you have to do it manually, it's a very complex way of describing the API. So KRO comes with a user interface where you declare that schema very lightly of what are the inputs to the API that you want to create that sits in front of like the group of resources. And then that creates you basically a new Kubernetes API on the fly by you just defining that. The things that bring along is that as you put together like a group of resources of other Kubernetes resources that live in the cluster, you're able to take output from one resource and use it as input. It's in another resource. Something very tricky to do, because for most part of the Kubernetes resources, they're eventually consistent. Like they'll retry until you get to the desired state. But in this case, these are resources that depend on the output. Like you don't know the output until actually the resource gets created, and then you pass it to the input. We'll talk a little bit more about what are those use cases are, and particularly when you talk about cloud APIs and cloud resources, that's the way they work. And using the cell, which is common expression language, to wire things, like to have expressions that say from this resource, from this object, take the input, take the output from this resource and pass it to the other one, or the inputs of the user of the schema API, passing in, and then use it in creating the resources. So common expression language is a language that is simple to learn. If you're familiar with JavaScript, or Python is an expression language, and one that is used in Kubernetes upstream in the validation and mission policy that got GA. I think it was 131. Got available out of alpha and beta, and then the last one is ordering. Sometimes in Kubernetes, you need to create resources in a certain order because of what I just explained. You have to create something first to get the output from that creation, to use it on the next one. And things like, for example, Helm is one that is very difficult to do that, because all objects are created at the beginning, right? So it's difficult to have ordering. And it's an open source collaboration between AWS, Google, and Azure, and many more companies. We made it open source. It has open source governance, and the project's just getting started. We are trying to set the schedule for the cadence of the meetings, community meetings. Usually in open source, you have meetings that get recorded. People come in with ideas, maybe problem statement, use cases, maybe talk about the roadmap. Right now is like how people are finding what is already there, the idea of like the inception of the project, Channing. So any questions on the open source project?
I guess no.
Let me see. Yeah, somebody shared the link to it's github.com crawl-run. They put it in the messages. Oh, we have people from the UK also joining. So we have some folks joining. So yeah, that's basically the crawl. But at this level, right, people may be lost of what does it matter, right, in terms of platform engineers, and these are the platformers. And the idea comes from, and I think we have some guests already in the live streams, in the past live stream podcasts, that have talked about they're building APIs to help developers deploy applications. And that's mostly like the primary use case of internal developer platforms, Shani. A developer comes in, wants to create an application. In this case, they want to deploy it to Kubernetes, and they want a database. In the context of a cloud, they'll be using a cloud provider. So in for example, if they're going to use Amazon, be EKS. If using database, could be RDS, which offers MySQL or Postgres, things like that. But the idea deploying to Kubernetes is very simple. People get started very simple use cases, I would say, for that matter, when it comes into like dependencies that live outside the cluster, like a service, like a object storage, right, and database. It gets more complicated. And the complications comes into large enterprise environments where there's like many developers, and they have an enterprise that is regulated. Like there might not be one cluster, there might be 400 clusters. As we had a session here in the platformers with Adobe, that they manage 400 clusters, so they cannot have developers just trying to figure things out. And that's basically like how that looks like. If a developer in a people creating internal developer platforms, or they have one that is not, that have multiple teams coming together to deploy this app. So in this case, they want to deploy to EKS and Amazon RDS. There's different teams that the developer needs to go to talk to. So what will be the networking aspects of like reaching that database, or what is the security around that networking, on like basically connecting that app to that database is the first problem. So they go to the network team. This is like when you don't have a central team, and then they go to the infra resources. Well, we need a database, or we need an object storage. If it's Amazon and S3 bucket, and they have to coordinate like what is the security access to that resource. The platform team will configure the database for the developer, and then they do another round, and then they go to like, well, I need to have a namespace. So some aspects like namespace as a service is very common, where a team of developer asks for Kubernetes a space on that cluster, and they get a namespace. So they have to coordinate that, and then they go to the last one when people build developer platforms is compliance, right? Things like if you're in Kubernetes or AWS, had different tools. In Kubernetes, you will use things like OPA, for example, or Gatekeeper, Kyverno. In RDS, there's many tools. In Amazon, there's many tools for compliance. But what is the compliance? And one example is like, compliance of keeping files. If you're having object storage, right, keeping files for X number of months or a year, or who have access or not. So that is the compliance of like dealing with that. So there's many things, and then on top of that, developers have to like schedule meetings with all these teams. So Chani, like this doesn't look like something that the developer has to do all the time when they onboard a new application. So in large enterprises, onboarding applications happens often. Small applications, right, Shani, like doesn't happen that often, because they do this maybe at the beginning of the project, and then they don't do this process anymore. But in large enterprise, they do this often, of like onboarding application and making sure that it follows all the guidelines and the standards in an enterprise.
And it's
Have you
becoming
seen
more,
something like that?
you have more teams, you have more things that you have dependencies on. This is like few lines here, which is already looks complicated, but as long as the company grows, it becomes more and more complicated. That's for sure.
Yeah, and then you can see different pipelines, right? Different, you can say different interfaces to do one thing, another interface to do another one. So there's like disjoint ways, this disjoint process, right? There's no a central way. So what teams are doing, and the platform is, this is something that we try to do here in the platform, is bring guests to tell their user stories around how they're building a platform, a central platform inside their company, and everybody's doing it in a different aspect, but sharing their best practices. Like the CNCF has a working group around product platform engineering, and also projects like the one I'm involved with, Canoe, CNOE project. We have brought some of those experts in to tell us like how they start, right, and where they are in their journey. So basically, this is kind of like what all of them look like. They want to have all these things like standardization, security, um, guardrails, passage, like centralized, but be able to have an interface that is an API to the developer or to the platform, or like coming different abstractions, but it lands into an API that the platform team can create this API. So that's where it comes like, what tool do I use to create that API? And so the teams that we have brought here want to do this, right? They want an API that can make the folks creating and setting the standards, right? The platform team handles the capabilities of like giving you compute resources, but in a optimized way, cost optimized way. We have security handling the permissions, and compliance handling the policies, and they all come together to create an API for the developers to consume. And for the most part, it could be an application running in Kubernetes, but it could be an application that doesn't run in Kubernetes. All cloud providers have different runtimes, right? Like in Amazon, we have Lambda, we have ECS, we have AppRunner, we have other compute resources. But in these teams, they have a lot of Kubernetes. So the platform team actually are experts managing, configuring, creating Kubernetes day in and day out. So they are experimenting, actually like being successful. Like folks that we brought in, like Cisco and Adobe, on creating CRDs, like APIs, to provide in Kubernetes, since Kubernetes provides all those capabilities, right? So if you look at Kubernetes, Kubernetes provides RBAC, has functionality so for RBAC compliance, like validation policy admissions. It has runners, right, to run the computer, run the program, and also extend the API, which is, I think that's where like KRO is coming in, of creating CRDs. That then those CRDs implement some logic, but the logic not necessarily has to be code of like programming something that does imperative things. Is coming together, like putting a group of resources together. That's basically what you want to create, like creating building blocks. So creating a way, an API that you can get um, some people call it stack, like a stack of resources or a graph of resources. I think we're going to be talking about graph in a minute. And then talking about those resources, and all cloud providers have this. Cloud providers offer a REST API to get resources into their cloud, like AWS, Google, Azure, and they have REST APIs. And the next layer of that API that they offer is SDKs. So you have SDKs for JavaScript and things like Go, and then for people that want to use that, they will use that. For people that want to create and those resources with Kubernetes YAML files or objects or resources, then there's Kubernetes controllers for all the AWS. Not all the rest. We have almost we have 50 controllers here, but it's a way of like a layer between what the user wants and then what the resources that you will get. So all cloud providers have this type of interface, having Kubernetes controllers to be able to create cloud resources. So this is the one that I'm going to show today for AWS. In the KRO project, you will find examples for GCP and Azure. But today, since I work for AWS, I'm more expert in that area. So this is open source project that we offer to the end users to get AWS resources from AWS using Kubernetes objects. Right now, this specific project is code generation. So from the API definitions, we're generating these Kubernetes controllers in Go. We're up to 50 controllers, and the team is creating more controllers as we speak, and we get more demand. And if you have a need for a service, AWS service that is not there, go ahead and open a GitHub issue or talk to your account team, and then the team will like put a priority on it depending what they have in the backlog.
I really think that
On
this
ACK.
project is super cool to control your cloud resources through your Kubernetes, just like a Kubernetes component.
Yeah, what do you get? What you get back, Chani, is that these controllers, right? The way that Kubernetes works is reconciling, right? So it's a desired state that you put in basically you declare in YAML that you want in, like, for example, an S3 bucket. You do kubectl apply, which I call kubectl, some people call kubectl, but you do kubectl apply that you want a bucket with this configuration, and then one of these controllers will run in the background, right? Like Kubernetes does, of saying, I'm going to get you that controller, and eventually we'll create the controller and give you back the status and maybe some of those things that I mentioned, like a unique identifier. In AWS, it's called ARN. Other cloud providers call it something else. We'll give you back the status. We'll give you back some of the generated IDs on that bucket. And if you change something like a property or configuration on that bucket, and you do kubectl apply again, like change that configuration, or GitOps, which platforms use GitOps, apply that change to that object in Kubernetes, then the controller will say, "Oh, it looks like there's some extra configuration that it needs to happen," and eventually will run. So there's no need to like have these one-shot actions that like it will say, if you change something in Git, then you have to run Jenkins, right, and then run it to get there. These controllers are running in the background. They're very efficient. There's very small containers, and I can support thousands of objects with a small amount of resources in memory and CPU. So that's the ACK project. You were going to say something, Chani?
No, I just said that it's super cool.
Yeah, and it's fully supported. I think I don't know where I think I put it in the other one. it's supported by AWS. It's not a community project. It's a well, it's a open source project, which the community actually end users contribute PRs. But if there's a critical issue or a CVE or something critical, then AWS, you can open a ticket with AWS, or you can open a ticket at GitHub, and it will get fixed. So it's not something like best effort. It's like something that we support with an SLA.
Carlos, we have a question. Paul asking, so these controllers are an infrastructure as code tool. How are they different from something like Terraform?
Yes, good question. In Terraform, like I mentioned, like there needs to be someone or some process that needs to run that module, and Terraform has a language called HCL. So you will write your HCL code, and then you have to have something that runs that Terraform. It could be a service, or it could be something like a GitHub Actions or a Jenkins that when you want to configure something, it would run it, and that would be the interface. These controllers are for people that are using Kubernetes, right? That they want the interface to be, instead of HCL, it could be JSON or it could be YAML, and it will be like flowing to the ecosystem of Kubernetes. So, and then the main difference is there's no Jenkins to trigger the configuration, right? Or deletion, for example. It will run on the background the way Kubernetes work, and it would just configure your Kubernetes resources. So yeah, it may look like infrastructure as code, but it's a little bit different in terms of like is Kubernetes controllers that work in the ecosystem of Kubernetes. So this is intended for people that, like I mentioned before, the platform team is already experts in Kubernetes and they do everything with Kubernetes. So they want to have like, well, let's use Kubernetes ecosystem to actually get those dependencies, right? Those cloud dependencies into the applications in Kubernetes, but also create anything in the cloud provider. In terms of I want to talk a little bit of effort. People compares KRO with other projects. Like I'll compare like two extremes. Like one could be on I think people say on the left side we have Helm. So Helm is a very simple syntax that you package resources together. So it's the same concept. Like if I want to package multiple resources together, I put them in a Helm package, I create a template, and the syntax is simple. It's basically you have expressions of like what the inputs that you get to that package, and then you pass them down to the objects that you want to create. But there's no quite ordering. There's some order there, but if you want a strict ordering, you cannot manage that order. All of the resources that get created at once. There's no wiring of like the output of resource when it gets created afterwards. You should run another one, and it's not intended to create a Kubernetes API. It's something that is outside Kubernetes that gets deployed, but it's not intended to create new APIs, extend APIs. On the other extreme, right, we have like a unicorn. I put a unicorn there because it needs to be someone that needs to know how to code with the Go, usually the Go client, the Kubernetes SDK, to create a custom logic. Like you're writing a program that does that. So it's a little bit more. It's like the stream of effort, right? Like you create a custom controller in your company, and that way, since you have full control with programming language, you can actually like create the order of resources. You can wire things, and then with those cube builder or frameworks, the CRD is auto generated even with the Go code. The API gets expressed like that. If you are doing that in your company, right, for the use case of not just wiring resources together, and you want to make it generic that in your company, then that custom controller gets used by anyone in the company to create any API. You actually to make it extensible, you're going to be ending creating KRO. So KRO sits in the middle where it's generic, that has a simple syntax. In this case, cell. It has the ordering, and the CRD, and the effort sits in the middle, having right, easy to code, but also having the wiring and the ordering. So it sits in the middle between the two extremes, like using Helm to the other extreme, using writing your own custom controller. So KRO sits in the middle where is generic that you can put resources together. It's inside the cluster, and then it has the wiring, the ordering, and then creates the CRD API on the fly for you in the Kubernetes cluster. So it's just an idea of like, if you want to envision like where this project lands, this is where it actually lands, and the kind of like the small differences between those two extremes. Do we have
Carlos,
a
we have
question,
a
Shani?
question. Yes, we have a question from Fabrizio. So Fabrizio is using Crossplane a lot. What do you think are the key advantages of using Crow over Crossplane, particularly in terms of simplicity, scalability, and multi-cloud management? Should it be considered as an alternative, as a replacement, or as something that could coexist?
I think that the Crossplane Crow, I think there's three projects actually: Crow, Crossplane, Kubevela, Catrix, Meta Controller. All of those are in that space of creating resources. Crow, if you don't need any logic like programming aspects of it, then Crow will be the one that you start with. Crossplane right now has functions, which is programming language. You have to write in Go, you have to write in Python if you need that extra control over, like it will be going more of the custom controllers, allows you to create custom controllers. And also the CRD schema is a little bit different. So right now I can give you the answer of as a solutions architect, Shani, which is what it depends.
It depends. Exactly.
But Crow it's something that is more than multi-cloud, or like the use case right now is for multi-cloud resources, and it's a good thing, right? Because we bring along the cloud providers to help with the project, maintain the project, and come with ideas and come like the use cases to get that use case, like I mentioned, worked out. But it's more than that. It could be just any Kubernetes resource not related to cloud, for example. And I will show a demo of that. That anything that is in Kubernetes, then it's kind of an ecosystem, creating abstractions inside Kubernetes, and hopefully we can make it part of upstream, right? I'm thinking that if we make a standard way of like extending, could be a cap into upstream. But right now it's very early. We're in release 0.2, and that's where we're asking the community to give it a try and see like, hey, these are the missing pieces that it would have for having something more generic or more productive for the use cases to actually work. But that's the idea of like opening sources early, right? Get feedback.
We have another question from Paul, and I will say that if you want to show the demo, so maybe after a Paul question. Paul said, great, thanks. So the controllers work on the Kubernetes system. Do they work as daemon set, props, sidecar cards? Do they have their own namespace or vCluster, or they work directly on Kubernetes control plane? And we have another question from Mariano. So after you will answer Paul.
Yeah, the first one was how did it run? I'll show you in a second. So Crow is a very simple control. It's one pod, which is in a namespace, and it watches over the resources. So it's very then the other objects that Crow put together could be anything in Kubernetes. So for example, I mentioned the ACK controllers. Those are also like a deployment. It's a deployment that runs one pod, one container, very lightweight. So it's easy to deploy. And that's ACK, right? If you're using the Azure project like ESO, or the Google project like KCC, right? It's simple controllers that you install once, and then once configure, and then forget about it. Crow is a deployment. So mostly those controllers are usually deployed as a simple deployments running on a pod. What's on the next question?
So Mariano asks, first of all, he said that great presentation. Thank you, Carlos. This is a great
Thank you.
presentation. So Crow looks promising. In the line of Crossplane, should we see less support from AWS on its official Crossplane plugin in favor of Crow?
Official Crossplane. I think I can tell, like I was one of the person. I'm still supporting end users using Crossplane. So Crossplane is used in production actually for AWS customers, but Crow is not a replacement yet. Like people should not be replacing Crossplane with that. And from the AWS support, they Crossplane is I think instead of plugins, it's called a provider that got added to Crossplane, and it uses Terraform, and then Terraform uses a the SDK of Go from AWS, so that's officially supported. So they're building on things that are officially supported by AWS. That Crossplane uses Terraform, and then Terraform uses SDK, and Terraform is very popular for people that are using Terraform. And again, it depends what are the interfaces that you want to use. For example. So thank you for the question, and I know there's a lot of questions around that, and I invite you, if you are looking into like comparing or like choosing, or you have questions, join the Slack. We have a Slack in the Kubernetes workspace, not in the CNCF, in the Kubernetes workspace called KRO, and you can ask there, and hopefully join the meetings when we start the community meetings, and then we can answer more of those things. And get answers, like not from us, like other people using Crossplane that are looking to move into KRO, or just looking at like comparing KRO versus Crossplane, and also kubevela and Catrix. Like the good thing about the CNCF, there's many options, right, to satisfy different use cases. It depends where you want to start, or how you want to combine them, right? There's another option of combining them. So I know that every time there's a new project, right, a lot of questions of like, well, this project looks like that one, how does it compare? And I think it's a fair ask. So I don't want to be like dishonest in terms of that. We're very open into having feedback and trying to answer those questions.
And someone from LinkedIn just post the link for it, so thank you.
Yes, if you the link is there, and I'll post the links in the comments when we're done on that. And if you log in into, yeah, we don't know the user, probably that's, I mean, one of the maintainers. So let's look at an example of because a lot of people like, when you describe these projects, are like, to some folks it's very complex, right? I have to say, and a lot of people say that Kubernetes is very complex, but this is more for people that are in the Kubernetes space. They work with Kubernetes objects, they know what they are, and in an enterprise setting, they even like more aware of all these things. So that's why they want to use Kubernetes to create these type of interfaces, because that's what they do on a daily basis, and that's the interface they choose, right? They're already in this ecosystem, so they want to have a better user experience in this ecosystem and provide better interfaces of using Kubernetes for platform engineering, for CI/CD, for DevOps. So let's look at an example of like, why do you need the ordering? Why do you need the wiring? Which is, I think, is what KRO brings in, and then some of the cloud specifics. So if we're going to deploy an application, in this case, the container, right? You build your web app, you put it in a container, you put it in a deployment, and that will give you a deployment. And then you create a service or an ingress to expose a deployment. And the ingress, by the way, it uses a Kubernetes controller. That's something that maybe many people don't realize. If you are using Kubernetes today, when you create a PVC or PV for persistent volume storage, right, file system that the app needs, and the app also needs networking, there are already controllers by the cloud providers that will create you the cloud provider resource. In this case, it will create a cloud resource called the ELB that users can interact with your app. But then this app, let's say that it needs to have needs to use a database, or it needs to use an S3 bucket. And that's where you would install the ACK controller for S3. In this case, S3 is the object storage in AWS, but other cloud providers have equivalent type of things. And then the ACK controller already lives in the cluster. So if you create a bucket .yaml, for example, and you keep it to apply, you get that controller, like I mentioned, it will runs on the background, and it gets you an S3 bucket. But the thing is that that bucket also in the cloud space, when you're configuring these type of things, you need to create a policy, which is another resource in the cloud provider. That policy will refer saying that maybe policy says whoever this policy says can only write, right? You can create a policy that reads, or maybe write, or depending what are the actions that you're going to do in the S3 bucket. But in this case, let's say that you want to write. So I want to write files to that bucket. So the policy, you can write it. This is where compliance comes in, right? I was mentioning the compliance team saying, well, this policy says um, the application only will have write access to that S3 bucket. And then I need a role, which is another cloud provider resource, which is the role we reference the policy. So when you create the S3 bucket, that may give you back a unique ID. Or if you have, if you're creating the bucket with an ecosystem that auto generates the ID, then you have to pass that ID to the policy, and then the policy will get you back kind of the unique ID. In AWS we call it ARN. And then when you create the role, you need the policy ARN. So that's why, Shani, I was mentioning some of the inputs to these parameters, to these objects, are like the output of the status of the previous one. So then the role would use the policy unique ID that you didn't know beforehand. It got generated because these resources sometimes platform teams create them with a prefix, and then the cloud provider give you like a unique ID. So you don't know that what that unique ID you're going to get to. Then when you create the role, you create the role. But for the pod or your container to access that bucket, cloud providers have a feature called workload identity. In Amazon, it's called pod identity. So in pod identity, you create an object or an API call against the EKS API saying, I want to associate the role with the service account two together, saying that this service account is going to have this role to be able to access the bucket, and that request gets sent to the EKS API. And all that in KRO, like, let's talk about KRO, you put them together. If you were going to put them together in a Helm chart, it's kind of difficult to create them because you need the wiring, right, and the ordering. So, but in KRO, we solved that by having a resource graph. KRO would know, as you declare these resources and the wiring, the references between one object and another object, it would know that which things needs to be created in what order, and also take the wiring, right, the outputs of one versus another. So it knows like it doesn't have to create one thing until the other one is created and you have the output of one. And that's basically what the platform team does, right? If we're going to divide roles, the platform team will create a resource graph definition. And this is definition that is an object that lives in Kubernetes. So the ACK, the KRO controller, it only has one CRD. It's resource graph definition, and then that's it for now, right? That's a part of the community talks of like if we need another one or this is enough. And then the developer comes along and it creates the instance. I want one of those. And then maybe another developer says, oh, by the way, I also want an instance. And then they put in the RCD and the RGD instance, they put like the inputs that they want. Maybe they put the app, their container image that they want to use. Maybe one container image is in Python to ask for the S3 bucket and it does one thing. And maybe another app team has like Java, right? And it wants to build a Java application that accesses an S3 bucket. So they can reuse this resource graph. Two teams together, separate teams can use the same resource graph definition, and the platform team provides the API and also decides what are the things that are going to expose to that API, which is that it's very important. I'm saying like, well, the developer doesn't need to put all these inputs, right? I can default a few of them, and then some of them I just have them the option, like put them and I have a default, or I'm saying like they don't get, this is our standard. The way that we create these resources is like this in the company, right? In the enterprise, and they don't get to like worry about that. And that's how they create that. Does that make sense, Shani, so far?
Yes, and I really love those features of KRO, to be able to pass the parameters, to have the order, to give the platform engineers the ability to set a group of resources and do it pretty much in an easier way if there are no Kubernetes. This is super powerful tool.
Yeah, it makes it more simple. Like it's not like this is the first time ever that uh sorry about that, that that this is not solvable. Like people have tried to do this on their own way, right? Creating, like I mentioned, like a meta controller or another custom controller, or even I've tried to use Argo CD, right? Argo CDs have something like post hooks, like create something and then run an imperative job, right? A job that gets the output from here and make them parameters back uh, to the next resource that it's going to be created, or like things failed and then eventually you get the output and eventually you pass it to the other one. And that those are, I think we had a conversation preparing for this talk, and those are the type of things that you want to avoid. You don't want to start creating these resources and hitting the cloud provider APIs multiple times until actually you get all the information, and then the one of those calls will succeed, because then you hit some of the cloud limits. Like the cloud provider will say that you have a rate limit of like X amount of requests per second for the type of API to protect the like denial of service or those type of things. In some other cases, if it's not a cloud provider API, maybe it's a different other API that it gets you like even like lower limits. So you want to like, if you know that you need certain inputs, right, it makes sense to wait until you have all the information to have a better chance of making the less calls to that API. Because at scale, when you're creating, you have a cluster creating thousands of S3 buckets, right, or thousands of resources in a large enterprise. You want to be efficient over that controller only doing work when it's necessary, right? Also, like the scaling of that controller, for example, the ACK controller, you want to maintain it like very lean and mean, of like very efficient, of like do calls that matter, and then like you get responses that are successful. um so let's take a look at some of the YAML files. What, right, Shani,
One,
you want to do that?
we can do it. We have two questions here.
Yeah,
So
let's pick the last one. Do you have an example
okay,
of, and then the last one, I think, is we're going to show it.
perfect.
It says, do you have an example dependency mapping between an example of a raw policy? Yeah, let's show that in action. So I think an abstract way is a little bit difficult to follow, but I think people get the concept. So let's see how it's the experience. Like I said, if you're watching this recording, this is using KRO 0.2 version. If you're watching this recording a year from now, we may be in 1.0. So this is the experience today, right? It should get better as we move forward with the project. So let me bring VS Code here and show you a example of a crow. So I have a let's start with a simple, actually the application I was showing. So in that application, let's say web app RGD. So we call it RGD. So it's something that which recently changed. It's called, instead of resource group, I think it was called, it's called resource graph definition. Um, and these are like the set. It has two parts. The first one, let's look at it. This is the schema which we call simple schema in the documentation, and it says it shows here that what is the API version. So in this case, v1 alpha 1, but you can put v1. I typically I took this from the example, but I think I'll start making my apps like v1. Then you put the kind. So basically, this is the new API that you're going to create in your cluster. It's going to be a web app. And then the spec is like, what are the inputs for the YAML file when you create an instance of one of these? And this would generate the CRD input, like the Swagger schema. So in this spec, it says like you're going to have a name that is a string, a namespace that is a string, and maybe defaults to default. So this is how you specify default. So in this case, this web app will take as input a name, a namespace, an image, a port, replicas, ingress, service account, and the S3 bucket name. And also defining the CRD. If you're familiar with CRD, it's this long document of like all the information that Swagger needs, OpenAPI spec v3. In this case, like a couple of lines, I'm able to define that CRD that would auto get generated. And then also the status. Like, so the idea is, if you're taking resources, right? The output from one resource into another. A KRO and this new API that you're creating, you can use it in another KRO definition. So now you're creating compositions and then having like object oriented programming, you can say, right? Creating kind of classes that you can use objects in another object. So this is the output of this. So I'm going to have the output of this web app will be the deployment conditions, right? It could be the available replicas that I can grab from the deployment status. So you can already tell that I'm going to have some of the resources at the bottom is a deployment, and then the URL, so ingress. So it looks like I'm going to have an ingress in this resource. So that's basically how you specify the schema API, the API. And then what are the things that I want to put in this web app? And then for the web app, I'm going to do it in a composed way. If I could put all the resources that I show in the slide, Shani, in one YAML file, but as people can tell, it becomes a very long file that is not reusable. So in this case, you want to build composable APIs that you can reuse as building blocks as you build more APIs. And then finally, with something like RBAC in Kubernetes, you can say, well, users get to use only this API. They don't get the intermediate APIs. So that's one of the benefits of using Kubernetes. So this is the status, and this will create you the CRD definition. And then resources is basically the controller, like KRO in the back. In the back, it creates like a mini controller for every set of instances of a definition. So it's actually creating a mini controller with the set of resources, and basically just reconciles this set of controllers based on the input that you get. So it's an array, but the order is not based on an array. The array is just, in this case, is a set. So all of them will be created at the same time, unless it finds that there's some ordering or orrowing. So in this case, it has a deployment, and then this deployment has a concept here called ready when, and it's saying this is the syntax. I don't know if I showed it at the top. This is the CEL, Common Expression Language syntax, that says this resource would not be ready, and ready means like it would not. If somebody needs information from this resource in another resource, it will not give it to anyone until it's ready. And then the ready, you can have an array of through booleans, right? So this comes into a boolean. So until the status is not available, then the whole API is not active. And then here you put basically a template in here. It will take any Kubernetes API that is available on the system. So if you install custom CRDs, it will be available here. So in this example, it's basically a deployment that we just put like the pod information, the labels, the container. So in this case, I'm going to use a container image, and then the image name will come from the input. So schema spec.image. This refers to the top section that says the input is an image. The port also. So maybe you come with an image and a port and come in. This is hard coded. Maybe this is the standard for the team, right? That puts this, or maybe it's an initial one and they use something like a Stormforge or something else that allocates the resources based on observing an AI, and then the bucket name, and then this will be like an input into here. And then the other object is service. So service will be created, and then it would use like, and then this is how you can refer to something from another object. For example, so in this case, I do a $sign deployment .metadata.name or deployment metadata namespace. And actually, this is something that we were looking into, like putting namespaces might be an anti-pattern, but just the name is needed. And then the app selector, right? The app selector that you put in the schema, I'm using this as a selector, and maybe the port, the target port has to be the one from a schema, or I can put it out from the deployment. So it creates a dependency. So in this case, since service is referring to something from deployment, it knows that it needs to creates that implied dependency ordering already. So as you can see, like without even think about it, like the system is at the background is knowing what is the order of trying to create things. And then the last one is ingress. So and also it shows one of the features is include when. So you can say you can control when this thing gets included by a boolean, and this could be whatever expression you want to be available. Like I'm going to include an ingress or not an ingress. So this is like tricky, right? Because sometimes you want to include a resource or not include a resource and include it there. And then this one is creating a service and then a service account with a service account name. So this is a way of creating a, because I don't think I'm showing a lot of, is that better? So that's basically the essence. And Chani, can you tell that I didn't mention anything about cloud resource?
True.
So that's the benefit, right? That you can put in here in this template section for the resources, any type of Kubernetes resource, right? In this case was a deployment and ingress service account together, and those are non-cloud provider type of things, right? So the idea is that you can compose things. So let's look at, I think we wanted to build a web stack. So this one is the S3, like I mentioned in the, I can show it again, right? The S3, going back to the S3, it needs an S3 and the policy. So maybe I decide to put the S3 and the policy together. So this is another resource graph definition, which you're going to create an API, a CRD, that takes a name and the type of access. So maybe I want to be write access, and then it gives back the status, the S3 ARN and the S3 policy ARN. And this is the output that I'm going to be using when I create the pod identity association. And then I create the S3 buckets, and then I create a S3 policy write policy, right? This is an API that is handled by the ACK controller, the cloud provider controller. So these are objects that are cloud specific, right? So you put this one in here saying that this is the syntax of specifying an AIN policy that allows to write to a specific bucket, right? So this bucket here is the name of the AIN of that bucket that got created up here. So as you can see, I'm wiring things. I can wire the value that I want here is from the S3 bucket, the status that comes from S3 bucket status. So the status of this object will have that value that I need in the policy and it gets created. And then the next layer, let me show the screen again. I need to create a pod identity association that I need the role ARN and the service account. So I create another resource definition that is a pod identity. And for this one, I need some information. I need the cluster name. I need the policy ARN. I need the policy ARN is the one that I got from the S3 bucket, but it's not specific to S3, so I didn't name it S3. The service account, and then the status, the output of this is the raw ARN and pod identity ARN. And with that, I can create a role that has that policy. Where was the policy? The policy that I created in the other definition. So I got my role, and then finally I create the pod identity association that has the information from the schema, and then some of them from the role. So I need that metadata ARN created, and then that'll be the spec, and that will create me the pod identity. So far so good. Shani, you following along?
Yes, definitely.
And then when I put everything together, so in this case, I'm creating, like, I didn't put them here, right? But I'm creating small resource definitions that I'm going to compose into the final one. And then that's the final one that I'm going to give the developer. So maybe I create artback saying like the developer can maybe see them, but it cannot create them, right? Only he can create the final one that I'm going to create. So the final one is the web stack. So the web stack is this one. So I'm going to create a web stack that would take, for example, a developer will give me the image, will give me the port, maybe gives me the cluster name that he wants to deploy, and then some of the status that I can give it back. Like I can give it back the raw ARN I can give it back the URL, right? He doesn't need to know like how I was able to create the ingress, or if I use Istio, for example, or some or a domain name that I already using for the apps. The developer doesn't have to worry about that. I'm going to give it back a URL. So that's the abstraction. So the resources that I'm going to put together is, remember the web app. So that's the first one, not the first one, but I'm going to create the web app. And in here is one way of creating a implied dependency. So one of the annotations I put here is, maybe I want to debug what is the raw ARN when I'm deploying. I can put this one here saying the pod identity status.raw. So this is kind of creating a, do not create the web app until the pod identity is like configured, because in EKS the pod identity needs to be created because there's a mutation webhook that inserts credential variables into the pod. So I don't want to create the pod right away. Then I create the S3 bucket. Well, no, I define the S3 bucket. If they want to use a S3 bucket, maybe I should just, this app is specific to web stack with S3. Maybe I just make it so. So I create the S3 bucket, but see here, this is the a KRO.run. So this is an API that I defined. It's not the S3 bucket from the ACK. And then I create the pod identity. So I include that when I'm using S3 bucket, so that's optional. And then I'm not going to put out any information from this pod identity until actually the pod identity is accessed. So this is a cell. This is the power of cell. You can do things. I wanted to show an example of a cell iterating over the conditions of this API, saying that if exists, and then comparing if is the type of a condition that it finds is instance sync, and the status is true, the pod identity is ready, and then it will be able to expose any information that any of the resource needs, and the web app will get that information, and then the web app will start creating. And then I pass the inputs from like the bucket ARN, the cluster name, and the service account. And basically, this is the API the developer will use, a web stack. So I think we're over 2 or 3 minutes. Let me run it. So if I go to instances, these are a couple of instances as I was testing, right? I'm testing, as you develop these things, you can test them individually. The small compositions, the pod identity, the S3, the web app. But in my case, I want to create a web stack with this image that is from a peer and AWS, Christina, that did this demo. This is a Python image that reads files and writes files to an S3 bucket. I want an ingress, and the access is right, and the cluster name is test cluster 32. And let's create that. Let me see if I'm in the right.
I think it's super strong to see how simple the user interface for the developers is with KRO. It's like super short, concise. I love it.
Yeah, and it will be in this thing is a demo, so I need to put more information that I need to, right? In a constrained environment where the platform engineers say like, no, we decide which cluster this app gets deployed, right? It could be 3 clusters: the dev, the prod, and the staging, right? And they can have a convention of which image goes to where. So it depends how the platform team wants to interact and what are the APIs that I want to give to the developer. So let's check the RG. So if I do get RGDs, these are the definitions that I did, right? I have a pod identity, S3 bucket, web app, web stack. If I do -OY, just if you want to try this at home, it has the topological order. Like in this order, these things will be created. So you can also inspect if you did something wrong, right? If you put a implied dependency or explicit dependency on what order they get created. I think people were asking how KRO runs. So if I do k get pods dash and KRO, basically this is KRO running. It's a single pod. A Kubernetes controller. We have a Helm chart that you can deploy it, and then in this case, I deploy this with Argo CD. So in Argo CD, I deploy the KRO controller, and I deploy the couple of ACK controllers. So in this cluster, I also have the, if I do get pods dash n ACK system, right? I have the three ACK controllers that I need because I'm creating the S3 bucket, the pod identity, the ARN role. EC2 I'm not using in this case, but I install it because I was testing to create an EKS cluster in the VPC. So that's another demo. So if I want to create this, where's that web stack? That's the file. If I want to apply it, I can do web stack with an S3 instance, and then I can start like inspecting what is the status. So I can do get web stack car demo, and this is what I created. So sync is false because it's in progress, right? It's creating things. So it's creating things like the S3 bucket. So if I do buckets, it's creating the bucket 22 seconds ago. Another thing that is creating is maybe roles. It's creating the role. If it's creating, what else it was creating? It was creating the pod identity, right? It's creating the pod identity. And eventually it should create the deployment, right? It created the deployment. It created the service. And it created an ingress. So let's check out the ingress. Okay, get ingress. And it created the ingress. And if I do get web stack dash OYAML, we can see the status. Let's check the status. So the status for the API that the developer created, right? He can get back these are the conditions that were from the deployment conditions. These are the ones that got copied from the deployment because I wanted to share that information. And I also put here the raw ARN. I also put the S3 ARN. I put the state active is something that comes with every KRO instance, and then the URL, which is this is the URL. So if we do a curl http against this URL, let me see, to have a health endpoint. It looks like I have the URL, but is created. So let's go to the AWS console and see some of the examples. So this is the cluster. If we look for the S3 bucket, I put CRO. So this is the S3 bucket that got created. If we go to EC2 and we go to load balancer, this is the load balancer that got created. So as you can see, it's getting provision. So that's something that I was asking the team in Slack of like, how do we get back the status of it? So this is open source. This example is open source. So this is we are like, we could put something like waiting for this to be available or something like that. But it takes a load balancer takes like 2 or 3 minutes to be created. Let me see if it's created. So load balancer, what was the other thing that we created? The cluster is this one where it created the pod identity. So in this case, I'm using one of the new EKS cluster modes, which is auto mode. So this created an EKS auto mode. This is a cluster auto mode. And then the pod identity, it was created here. So this is the role that have access to the S3 bucket. So if we look at the role, you can see the permissions that we created. So all these AWS things, the platform team is the expert on this. The developer doesn't have to be an expert on these things. As you can see here, this is the bucket ARN information that he only have access. This role only have access to this. So this app can only read and write from this location. So let's see if it's up. So we can see the app to show the app. Yeah. So the app is running. And if I open in a browser, we move it over here. This is the endpoint, so it's healthy. It's what's TNS to come up, and then this is the bucket that I'm accessing. So I can put hello.txt. I can put hello platformers, and that basically created a new file or a new key in that bucket. I can refresh and it's there. And I think I was looking at the bucket a second ago. We can see the file in the bucket just to double check that it's working. And then this is my hello. So I created an app there. And then when the developer wants to delete it, it can delete it. Just take into account that the bucket needs to be cleaned up first, and it can delete that app. But they can see the status. So if there's any change or configuration change that they need to do through this input that will reflect in one of the definitions, it will reconcile, right? It will see that there's a change and it will reconcile, and that new configuration gets added to the app. In this case, this is a very simple app that I did. And one more thing that I want to show, if I have time, Shani, is that that cluster that I was using test. It was an EKS auto that I created also from ACK. So you can create like compositions that are like a deployment, a pod, and then a pod needs a cloud resource. But platform teams are trying to create like we had Adobe in the platformers. They're creating clusters, Kubernetes clusters using Kubernetes controllers. So in this case, I can use the same for creating a VPC, for example, networking. So in this case, I have a VPC, a network stack, RGD. Where's my network stack? So I'm creating an API that allows me to create a VPC with all the things that I want to create an EKS auto cluster. The VPC, the internet gateway, the routes, the subnets, right? I can create that as a RGD, as a definition. And then I can create an EKS cluster that takes this information from the network and create the cluster role and the node role and an EKS cluster with auto mode configured, and then create a compose RGD, which is an API, right? It's an EKS compose that I put together the network and the cluster. So we're looking into using like external configuration. That's something that we're looking in the roadmap. So you can share an existing network, right? You don't have to create a VPC every time you create a cluster, but you can put a cluster into an existing cluster, an existing network, and create a new cluster. So let me run, which one did I put here? This one is a platformers EKS compose. So I'm going to start this. This takes like 10 minutes to create it gets a few minutes to create and then to become active. So if we go and create this one, so it's not just, I can create VPC, I can use SageMaker, I can create a lot of cloud resources that not necessarily go in pair with a pod. That's what I'm trying to show. So if I do cat EKS cluster.instance.auto, right? I want to create an EKS cluster that is, the name is platformers, is version 1.32, and the platform team took care of like all the settings and the other things that you want to create and also like deploy. So it may be an EKS cluster with add-ons, with Argo CD, with Podident, like everything that is needed to create a cluster. So if I apply this, instant-auto, I installed it in the wrong cluster. So if I do kubectl ctx kind, so I'm using in this case I'm using a tool called IDP Builder, which is from the Canoe project. So I have like a platform engineer Kubernetes cluster that is acting as a deployer. So let me see if I run it again, and it's on this cluster that I need to do it. There you go. And I can do EKS compose. And I have one that is error, is progressing. So it may be something wrong with this. Let me see if VPC got created. If not, I think I changed a few things. Platformers. Yeah. So I think it's eventually like getting some information. So it's checking that the state is not there. So it's not showing progressing because I have an evaluation saying that the cluster is not active until it gets created. So it's created. So it would not be successful until like 9 minutes from now that is in active state. So it's creating. So that's how you can create a EKS cluster, Chani. Let me see if there's any questions to answer. But yeah, this is the way that the platform engineers are looking into composing resources and then offer them as an API that then you can do. I show kubectl apply, but you can use something like Argo CD and GitOps, and then as people put these files in Git, they get deployed to the control plane or the worker cluster, depending which cluster you have the right controllers. Like I showed you the worker controller, you would not be creating EKS cluster from the worker controller or worker cluster. You will be creating from the management cluster, which I have Argo CD running.
Perfect. So we have a question. Actually, this is a nice one. Preet asks you, can you repeat everything again? Which is a good sign. Short question. So
Yeah.
I guess that you can see the recording afterwards.
The recording, you can watch the recording and use the repo. Yeah, and the KRO is in KRO.run. There's the documentation here, and also pay attention. There's like examples here. So some of the examples that I use are here, like creating a cluster, a network stack, the S3 with a pod. But also you can look at the other cloud providers. GCP is here. Azure, in the repo, you will find Azure ones, generic Kubernetes ones. You find them here. And if you want to know more about cell, for example, using it in cell validation is here. And then also there's a cell playground that you can like check and check your evaluation. So there's a set of cell functions that we support for strings and lists and those type of things. So yeah, you can check that out. That's information about cell, why we're using cell. I'll share the slides when they're available. There's many projects using cell, like Dapper, Kernel. I mentioned the validation policy. And then in the roadmap, we have like things that the team is the community discussing, right? What are the things they see they need? Like collections is one that I brought in, of like that's a good way of like creating multiple of things, right? Like I want to create multiple subnets. I don't necessarily want to hardcode the number of subnets, and also like CLI and OCI distribution. Like if I create my definitions, how do I package them and put it into an OCI, an image that then a CLI can like version them. So versioning is something that we're also discussing. So yeah, check it out. Check out KRO.run. And then this is a project that is getting started, and it's a good opportunity to get involved into like Kubernetes abstraction. How does it look, the next level of Kubernetes abstractions?
Definitely. So thank you so much, Carlos. It was a pleasure. And I super enjoyed my first webinar with the platformers. Next week, we are going to talk a bit about serverless platform engineering, which is super cool. And yeah, I hope to see you soon.
Yeah. Follow us in the LinkedIn page and watch the recording either LinkedIn or YouTube.
Definitely.
Thank you so much.
Thank you. Bye-bye.
Bye.